Good morning, everyone. My name is Guna. Thank you for joining our second workshop in our series. We are really excited that all of you can take the time to join us to hear everything about the new second workshop. The title is Technology and Systems. We have a great panel, great set of speakers lined up for you. So let me take a moment to introduce our anchor for the evening. So anchor for the evening is like my good friend Anindya, who's right there. Anindya is a CTO at Sankhya Labs. He's got about 26 years of experience. As you can see, he's a very active participant at IEEE, 3GPP, ORAN, and you can see that he's passionate about the kind of work that we're doing here, standardization. And besides that, he's also an active researcher. His expertise is in 5G radio, broadcast radio. He knows all about radios, and he also has a lot of patents and publications. So over to you, Anindya. Please take over. Thank you.
Thank you, Guna. Thank you, everyone. Welcome to this second micro workshop of the DoT-TSDSI series. We have a very packed agenda today. As you can see, today's theme is technology and systems. I think in the first one we touched a little bit on the spectrum aspects, but today we are going a little bit deeper on further work that is being done in 3GPP for release 19, and we have a very good lineup of speakers. So today we'll be touching upon study of network service robos. Then traffic steering is one of the key topics, then followed by AI/ML, and then integrated sensing and communication. So I'll, without much wasting any further time, we'll go to. I would like Dr. Abhay Verma from TEC to kindly go to the speak some opening remarks. So just as an introduction, Dr. Abhay Verma is a DDG MT Mobile Technology, heading the Mobile Technology Group in TEC, and he looks after the standardization of mobile technologies. He has more than 30 years of vast experience in telecom, and of course he has participated in a number of international seminars and conferences, both in India and abroad. We'll go to the, so Dr. Abhay, over to you for an opening remark.
Seems you are on mute. At least I cannot hear.
Dr. Abhay, you are on mute.
Dr. Abhay, you are on mute. Can you kindly unmute yourself?
Okay, I'm sorry. Welcome everybody to this webinar, and this is the second webinar, as has been mentioned in the series. The topic being towards 6G, what we are going to do in near future, and how TSDSI is moving towards 6G. And I'm honored that TSDSI has provided me this opportunity to address this particular seminar in as opening address. So as everybody knows, India has leapfrogged a lot, and especially in telecommunication domain, and this has proved to be a growth engine for Indian economy. And especially during the pandemic, everybody has seen that the telecom services have been very useful, and it has come to the rescue of many things, especially during the pandemic. And nowadays, even in financial transactions, this particular facility is being used extensively. So as far as standardization of telecom network and services and products is concerned, TEC is is the standard setting organization for India, and TSDSI being the SDO, Standards Development Organization, which is also a partner of 3GPP, one of the organizational partner. Then, as you may be aware, 3GPP is working towards the next generation. Release 17 has already been frozen. Release 18 work is going on, and now nowadays we are talking about release 19 standards. So this particular seminar will provide you insights about how the TSDSI is moving towards that goal to achieve leapfrog in and take leading role in 6G. So with these words, I will not come to the way of all the speakers lined up today. So with this, I open the seminar and wish this seminar a great success. Thank you.
Thank you, Abhijit, for your opening remarks. We can go to the next presenter, please. Can we turn the slide? Go to the next slide, please. Yeah, so I would like to introduce Dr. Samar, who is the first speaker today. He's going to give an overview of the 3GPP and release 19 timelines. Samar is a senior standard architect at Intel, and he's very active in standardization in 3GPP, an active contributor in SA6, and he's also the roadmap chair and of TSDSI roadmap committee and the vice chair of the study group network. So Samar, without wasting any more time, over to you.
Yeah, thank you, Anindya. Thank you for this introduction, and thank you, TSDSI and the entire committee for giving me this opportunity. I'll briefly touch upon about the 3GPP ecosystem. This is the second workshop. We introduced the about 3GPP and the timelines in the micro workshop 1 as well. However, because there can be new candidates, new participants for this workshop, we thought it would be good if we can touch upon this particular presentation in a very, very brief time once again, because this is something which is a very elaborate topic in my opinion. I believe pretty much everybody knows about the 3GPP. 3GPP is consisting of the various partners across the globe. It's consisting of 7 SDOs, which are ranging from China, Europe, India, Japan, Korea, and the US. And it also consists of the market representative partners, for example, the COI in India and the GCF and others, who provides the requirements and the market vision to 3GPP to create these specifications. And every organizational partner, for example, TSDSI, brings the individual members who ultimately contributes to the actual work which is happening at 3GPP. Next slide, please. So as I said, 7 organizational partners from 6 different countries, because Japan has got 2 SDOs participating there. One is TTC and there is Arab. Apart from that, we have ATIS from US, CCSA, HC from Europe, TSDSI from India, and TTA from Korea. Next, please. Something which should motivate everyone to contribute to 3GPP and what makes 3GPP a truly global initiative. It's a 23+ old organization now. It has all these specifications ranging from 3G to 4G and then to 5G. It has got a huge number of specifications, which has been happening across every release. So more than 10,000 specification on an average gets produced in every release, which happens. Now we are running in release 18. And there are more than hundreds of thousands of contributions which come from the members. Every meeting sees huge number of participations and contributions coming, which becomes very difficult to handle if you participate there. Lot of meetings time which has been spent, and most interestingly, there are 750 individual members companies. So when I'm saying 750 plus, these are the organizations which are participating in 3GPP. That itself shows that pretty much a huge number of ecosystem is participating, followed by 16 different technical groups where actually the technical work happens. So some people who are, we will talk about the technical working groups in a while. Next slide, please. A quick look, what is an individual member? Individual member is a organization company which joins 3GPP from the organizational partner. For example, through TSDSI. So first, as a company in India becomes a TSDSI member first, and through the virtue of being a TSDSI member, they also get the individual memberships at 3GPP, which they can join on the to the 3GPP if they desire so. And that's the way how you can participate and contribute to 3GPP. So this allows you to participate in the specifications meetings, the working group meetings, the TSG meetings. You can influence the leadership there. You can influence the technical work there, and you can participate in all these meetings and specification creation process. Next slide, please. About the organization of 3GPP, the 3GPP consists of a project coordination group, which is the apex body of 3GPP and takes care of the entire coordination of the entire 3GPP project. Because as you can see in the name of 3GPP, it's a third generation partnership project. So it's a project in itself. And this project coordination group, PCG, takes care of the entire organization. The entire 3GPP work is divided into three particular specification groups, or TSGs, technical specification groups: the radio access network, the core terminal, core network and the terminal, and the services and systems aspects. The RAN group deals with all the RAN related aspects. It has further been divided into 6 working groups, RAN 1 to RAN 6, which focuses on different aspects of the radio access network, ranging from the file layer aspect, the MAC layer, LLC aspects, the related to RF issues, protocols, etc., conformance, etc. So as you can see, there is a huge gamut of horizon which they focus upon. At the same time, the system and architecture group, which we call as the SA group, has been divided into 6 working groups, SA1 to SA6. And these take care of the different aspects of the core network, whether it's related to the services, the architecture, security, codecs and media, telecom management, and the one where I participate is SA6, which is about the application and the services. The third group is the CT group, which is about the core network and terminal, which is the one which actually creates the deployable models of the 3GPP work. So it converts all the architectural and RAN aspects into the actual specification which gets deployed. So it has been divided into 4 groups. Some of the groups have completed and discontinued. So 4 are remaining, which focuses on the aspects related to the protocols, the application aspects, etc. Today we will be talking specially about the SA1, which all the speakers will be talking about, because the SA1 is the group which generates the requirements for any release. Next slide, please. So this is how the entire specification process happens. You first collect the requirements, followed by the architecture, followed by the protocol. So the requirements gets gathered by the SA1 group, which gets into the architecture, where SA and the RAN groups derive their own specifications, followed by the protocols, where different groups, whether it is CT groups primarily, but many other groups will also focus on the protocol aspects. And finally, we go into the stage 4, where the actual specification generation, conformance, deployments, etc., and maintenance happens for all these work which has happened in a particular release. Next slide, please. this is how the TSDSI has organized itself in terms of the the way the work will happen, especially for the release 19. So what has been thought through is we will undergo a series of micro workshops like this. So as you can see here, that micro workshop 1, 2, and 3. So today we are in the micro workshop 2. This is the workshop where we are going to talk about all the release 19 studies, and I am personally very thankful on behalf of TSDSI as well for all the speakers who could spare their time to give us insights on the ongoing work in the SA1 group. So SA1 is the one, as I mentioned, which is studying the requirements for release 19, and we are looking into the more details about those studies in their subsequent talks. Based upon that, typically how 3GPP does, 3GPP completes the study, followed by they do a workshop. Earlier, this essay was supposed to do the workshop in March time frame, but it has been moved by a quarter. It will happen somewhere in June time frame during SA 100. So that will be the time where the first workshop will happen. Followed by there will be a content approval which will happen, which actually is the time when you decide what you are going to do as part of the study. That has been moved to the September, so that content approval will happen, followed by the first the essay content approval, then the RAN content approval in December. And at the same time, at 3GPP, at TSDSI, we will continue with the roadmap activity. There is something called a trip forum. So we will have a poll coming towards the end of all these sessions when we're done. I would strongly encourage everybody to participate in that poll, because that will give us insight about your level of interest, your place where you want to participate, and so on. Next slide, please. So as I mentioned, the next step will be that you participate in those trip forums. You can join those trip forums. It does not require any TSDSI membership. There will also, apart from the poll, there will also be an expression of interest form that will be emailed to you. You can fill that form as well, or you can send out an email to Mr. Preetham Bishnoi, who is coordinating all this effort. If you're interested in 3GPP and you want to contribute to release 19, the process is simple. You join the TSDSI, acquire the 3GPP IM membership, and rest of the stuff is formality. I mean, the secretariat will be very happy to help you from TSDSI, or you can also look at the 3GPP website for the working processes. Once again, just to mention, please answer the poll questions, which will happen towards the end of this workshop when all the 4 speakers have completed. Do fill out the expression of interest form. Please don't forget that. Take your time. If you have any further queries or any information you need, please reach out to Preetham Bishnoi or any one of us. Thank you very much. Next slide. I think that's it. Yeah, these are some important links which you can refer to. Next. You can write to me. Thank you very much. Sorry for being slightly taking more time. Over to you, Anindya.
Thank you, Samar, for that very crisp presentation. I believe I think this gives a nice overview of the entire process and how the release timelines are lined up. So people who are interested to contribute should really take note of that. And of course, if there are questions, they can reach out, as he said, as someone mentioned. So let's go to the first speaker in this for the session today. Let me introduce him, Mr. Ki-Dong Lee. He's AVP at LG Electronics North America, and he's a very active researcher and a 3GPP contributor. He served as the first 3GPP V2X rapporteur as the workstream chair, and also as a workstream chair of Engineering Alliance, V2X task force, and also 3GPP SA1 vice chairman. So welcome, Dr. Lee. He's also a cloud robot enthusiast with focus on how to help technology across various disciplines and better design to assist humans in various settings. He's currently serving as the chair of the application working group in the NextG Alliance at AT. So over to you, Dr. Lee. for your presentation.
Right. Thank you very much, Mr. Anandya Saha. It's my great pleasure to have some presentation for today about service robot in 3GPP. So today's agenda includes, as you can see here, so I'm going to briefly go through a brief definition and the business aspects, and more importantly, about recent 3GPP activity about robotics applications. And then the last thing, but not the least, I want to have some update about the study item objective and the progress. So next page. All right, so this one is showing briefly the definition of industrial robots and the service robot based on the definition from ISO, International Organization for Standardization. So a little bit different from industrial robots. Service robot is defined to be playing a certain role, useful role for human or humanity in typically unstructured settings. So examples are, as you can see, in many different areas. So restaurants, delivery, and caregiving, and hazardous control, and many things around. So next slide. Can you go to the next?
Can we go to the next slide, please?
So number 5. So I want to give some idea about where we are at right now globally. So we have a lot of achievements and advancement in the context of telecommunication technology evolvement, so that we can apply those technology validly for industrial settings, including industrial robots in various settings, mostly in structured settings. But now we believe that there are global trends such as aging population and some concern about environmental sustainability risk. So we still have a lot of business opportunity plus research opportunity, so that we can bring those type of robots or robotic applications to our everyday living environment. So that's what we want to mention or describe with the picture in the left. And in the picture in the right, you can see many different type of usage scenario. But this one doesn't have, unfortunately, doesn't include some hazardous control or rescue or public safety related applications right at this moment. So next slide. In the next slide, I wanted to show that how much we can do about service robots for next slide. The table. Can you go to slide number 6? Okay.
Yes, I've switched pace. Sorry.
Right. Yeah. So we have something, some hope that we can do with the service robot in various settings of our daily living. So typically, we have 4 different categories of applications: societal goal achievement and critical roles achievement, and service robot as a machine, intelligent machine, can also belong to the categories of applications on user experience or immersive experience area, such as healthcare related and retail related, and many things around. So that's going to be something we can discuss later a little bit. And more importantly, everyday living environments, we have many various type of application field for the service robots. But we don't think a service robot is the only one. We can provide some new type of or emerging type of services that's going to be needed in the context of societal change, including population aging. And the next slide. So if we go to agenda item number 2, that is about 3GPP, recent 3GPP activities. Yes, thank you. So here, the study item of Sabot is not really about some single robot operations, even though the robot is through cloud-based operations. So the thing we really want to do is a group of robot operations, it's basically group operations, so that what type of reliable or agile type operations we really need from the telecommunication layer. So that is basically the focus of the study item. We want to get out of this activity. So if we can briefly review the related prior study or work item in 3GPP, we can definitely bring up a V2X, which include platooning and remote driving, which is going to be remotely or tele-operated vehicle. And in release, I believe 16 and 17, we have a very fascinating study and normative work, which is about UAS or UAV. So basically, in the context of group operation of certain machine or robots, we also handled swarm of flying bots that do something over the communications transport. And more importantly, through release 15, 16 study, we 3GPP also developed a certain type of concept that defines very important applications layer and communications layer requirements, which is about, which is in short, industrial robots. And also, the medical robot applications were discussed in the context of tele operations. So as you can imagine, so medical related applications, especially with the robots, we need a lot of rigorous KPI, including media transport related, like very low latency, high data rate, and compression efficient type of solution that should be kind of some enabling preconditions for successful implementation of medical robots. And in all, we need to provide some basically multi characteristics, which is oftentimes referred to as multi-modality support over the 3GPP transport. And also we need many different aspects of features, such as high accuracy positioning and sensing, which is being worked on in 3GPP SA1. Okay, next slide. So from here, so this one is a little bit of a justification why, or background, why it is valuable to consider and study the service robots, the group of service robot operation that has some intelligence. So here, what I mean by ambient intelligence. So ambient intelligence is still part of AI, not human intelligence, but artificial intelligence. But what we typically mean by ambient is that certain type of intelligence, which should be very compact and efficient, and also the outcome of which can be utilized directly to the need of human being. So that's what we wanted to mean by ambient intelligence. So if we can go to the next slide, we can talk about the objective of this study. So this study has two factors. By the way, this study is going to produce 900 series technical report, which is a little bit different from the 800 series technical report. So one of the factor that this study is going to achieve is to identify new aspects that are relevant to support group operations of service robots. It doesn't have to be group of service robots, but it can be a group of everything, a group of industrial robots and group of combination of industrial and service robots, whatever. So basically from here, I think the binding factor is going to be, for example, how we can provide a very reliable and efficient exposure picture so that the very reliable and powerful API can serve the need between the compute layer and the communications layer, so that we don't need to waste our valuable time or opportunity or whatever when it comes to robot launched type of services, because robots are expensive. They are going to do something very important or critical to any corner of human life, right? So that's why. And the third thing is still important aspect for some time critical operations of those group of robots. And the next one, support of the next one, the requirements related to media applications, that is really about the robot per se. Robots talk to robots, not human in the middle. So robot may need very high dimensional, a context of a media, including audio, video, or whatever, so that they can understand which human doesn't have to or human can't. So that is one thing we want to study. And of course, we still have to discuss from value indicator such as security, privacy, and trustworthiness and resilience, and including some ethics when it comes to the automated decision making coming into the robot operations. So next slide. Yes, thank you. So the robot operation is closely coupled with many different aspects that are studied in 3GPP. So not only 3GPP communications layer aspect, but also some compute layer or network fabric related aspect, including cloud, what is it, the edge service or something like that, so that how we can smartly manage the compute load, and also how we can achieve some agility of a certain type of actions that can be coming out of the robot operations. So here, so it is very important how we can describe and pinpoint what type of feature is really needed in the context of technology development, filling the gap between many different type of features that were or that are being defined in 3GPP. So with that, I just want to go to the next slide to quickly summarize the plan or the progress here. So we are still developing the technical report in 900 series. So we are right now we are studying use cases. So as you can see here, some interesting use cases, online cooperative, high resolution 4D or 3D map building. And we also have a safety related aspect for the robotics operations. And if we can go to let me see, the slide number 14, in the interest of time. So slide number 14 is going to be the plan for the rest. So next one. So I want to, next one. I want to briefly wrap up by talking about the plan next here, right? So a little bit different from the other Release 19 study item in 3GPP Essay 1. This study is going to bring some attention to the group operations of robots. So that is main focus of this study, and the objective of this study. And we are going to continue to collect different type of use cases that are very relevant to our daily living environment. So with that, I think I want to conclude my presentation, and thank you for your attention.
Thank you very much, Dr. Lee. I think this was a pretty, interesting presentation regarding the service robots and the work done in 3GPP regarding that. So, I appreciate you, at this time of corresponding to your California time zone for taking time to be with us and, conveying your knowledge regarding the work being done. Thank you very much. So we'll go to the next speaker. Can we go to the next slide? Yeah, so the next speaker is Mr. Francisco Pica. He's an employee of Qualcomm and has been very, very actively involved in standardization process for about 15 plus years. He has, worked across a multitude of generations from 3G to 5G, and has been part of various 3GPP groups, RAN 2, RAN 4, RAN SA1, I think, and so many contributed to so many releases, release 17, 18, and of course continuing. So he's the rapporteur for this study on traffic steering. So over to Francisco. Francisco, thank you. We can go to his slides.
Thank you very much, Anindya, and thanks everyone, also from my side for the opportunity. So I'll try to provide a quick overview of the status of this study in SA1 that is targeting Release 19. So here you see at a glance some of the reference in terms of the study item description, the TR number, and also the progress. So we are now around the 60% completion, and we are targeting, as most of the other studies, to complete in June. So basically 2 more meetings, but we'll probably discuss a bit more on the plan at the end. On the right, you see the general scope, which is at high level to provide new and enhanced functionality to steer, split, and switch traffic coming from the UE across 2 GPP networks. This is, of course, not something that is completely new. As you know, there are functionality at the RAN level that can do that. But here we are looking at functionalities that are above RAN. And target scenarios have the assumption to use for the 2 GPP access, especially when you have the 2 networks are across 2 elements. The assumption that you would use 1 single subscription. This is to simplify, of course, some of the scenarios. Initial proposal including also to consider dual subscription, but the agreement eventually was to limit, at least in Release 19, the focus on single subscription. In terms of different PLMN, all scenarios are included, so it could be 2 networks under 1 PLMN, or different PLMNs, or even a PLMN and no public network. In terms of combinational routes, Also there is more or less no restriction, so it could be NR plus NR or ultra, where the other NR or one of the two NR could be terrestrial or satellite. Here you see the current list of use cases, but of course it's expected that there will be a few more in the next meeting, and then we will start to consolidate. Requirements are only functional requirements, so it will not be KPI, because as a certain study define both type of service type requirements. So in this case, it's all about functional capability of the system. And as I said, the system impacts target mostly UE and core networks, so there are no, at least foreseen running impacts at this point. Next slide, please. Thank you. So as I said, first of all, it's a functionality at the higher layer, so it's something that may complement other functionalities already available at the RAN level, like dual connectivity or carrier aggregation. But in certain cases, you may not have those solutions available. For example, today, this functionality at the higher layer is already defined since release 16 for one link, which is a 3GPP access, and another link, which is a non-3GPP access, or let's say Wi-Fi. So this feature is called DoT-TSDSI. And again, it's there in 3GPP and it's been evolved. In release 18, now there is even more enhancements to add, for example, new policy to split the traffic, or even new protocols like Quick and so on. So in a nutshell, what we are proposing, in fact, is to extend that feature to the scenario where you have two access links that are using 3GPP access. So that's the figure at the bottom. So in that sense, it's also not a kind of revolutionary or completely new type of functionality. So it's already defined there for 3GPP and not 3GPP. Next slide, please. Thank you. So here there are a few slides that capture some of the pictures that are in the TR, just to give you an overview of what type of scenarios and combinations of PLMN and RATs are there. So this capture three examples of inter-PLMN scenarios. On the top left, you see a case where the two access link use satellite. On the right top side, you see a case where you use two terrestrial networks, and it could be LTE going via EPC and NR going via 5GC. And at the bottom, you see one scenario that is using a mix of the two, terrestrial and satellite. In particular, one of the terrestrial, the one at the bottom, is using GNOB mounted on a UAV. So this is actually a scenario that is coming from one TSDSI company. I think it's IIT Bombay. Next slide, please. We go into some inter-PLMN scenarios. So on the top left, you see a case which is also mentioned and referring to more than one use case in the TR. It's a classic one where you have a local coverage, for example, a stadium that can come by a PLMN or an SMPN, so a local network, and a PLMN that covers, not only the stadium, but also outside, or with coverage that comes from outside the stadium. So in that case, of course, it's one of the useful scenario where combining or having connectivity from both can, of course, include throughput and so on. On the top right side, you see two PLMN. So in the left case, it's both terrestrial. So on the right case, at the top, you see terrestrial plus satellite. And in this scenario, there is also the additional type of functionality where you may have one connection, like the, in this case, is the blue one, sorry, that is a single or a traditional type of single connectivity. And another application that is using instead dual connectivity, one over terrestrial together with the one over satellite. So that's also another functionality, another requirement specific for this use case. And the one at the bottom is a kind of mix of the two. It's a very complex scenario where indeed you can have a combination of different RATs and you could have, you can see in the boxes at the bottom, you can use satellite only, or 2 satellites, or satellite and terrestrial, and so on, depending on the location. In this case, it's a maritime scenario. That's all for the inter-peer element. Next slide, please. We go into other scenarios that were discussed at the last meeting. So most of the use cases discussed before were somehow included in the case where one of the peer elements is the home peer element, and you are using another peer element for the second access. These scenarios, at least the one at the top, now cover the case where there is no home peer element in the picture. So basically, maybe you are abroad, or you are in a whatever location where you are indeed roaming in a VP element. So in that case, also that functionality should be possible. So these scenarios cover that type of case where you may have the dual connection over 2 routes or over 2 networks belonging to a VP element only. And the traffic in this case could be either routed to the home element, or that's the picture here, LBO stands for local breakout. The traffic could even be transferred over the data network via the VP element itself. On the right side at the top, you see a little complicated case where you have 2 VP elements, and you are doing, you are combining or aggregating traffic over the 2 networks that are both VP element. For that scenario, there is a restriction that only the case of home routed traffic is or should be relevant or supported. So at least the requirement focuses on that, again, to simplify a bit possible stage 2 and 3 impacts. And at the bottom, you see another type of scenario where indeed now we combine basically the support of this legacy ATSSS, the one between 3GPP and Wi-Fi, and this new functionality over 2GPP access. So basically, it's a transition between the 2. Outdoor, like on the left side of the picture, at the bottom, you see using 2 terrestrial routes. And when the UE goes inside, maybe one of the 2 cellular links gets worse, and then it's good to switch to Wi-Fi, and maybe you can still have higher throughput by aggregating over Wi-Fi and cellular, using one of the 2 cellular links that is still good. That's all in terms of use cases. Next slide, please. So the next slides are a little bit boring in the sense that I kind of capture the current requirements that are in the TR, split by inter-peer element, inter-peer element, and others. So of course, I will not go into the details because first of all, you can read the TR, and second, from the upcoming meeting in February, we start to consolidate. So in fact, what I want to show you is also that many parts of these requirements overlap with each other, but that's normal. So it's part of the study and the initial set, right, of use cases that come with requirements that, of course, can have some parts in common. When we consolidate, of course, we will filter out the main differences. And what I try to do in bold is to highlight some of those key parts of each of them. So the first one is basically what is called the basic requirement to support the general functionality. And you see also the latest terminology that was somehow where we are converging to. So just to mention the support of this mechanism to enable a steering splitter switch or use the user data of one application across 2 GPP networks. And then, of course, depending on the route, each use case has the examples of the specific routes, but you see more or less all the combinations are covered. And in this case, it's for the same peer element. And then you see in italic also, I try to highlight the different examples of policies or conditions, criteria by which this traffic can be still switched or split. So you see the different use cases introduce different examples. Some of them, of course, overlap with each other. So in the again, the second and third, you see also some other notes and assumptions that are coming with the requirements. So the anchoring, in one of the 2 networks. There is the second use case covers also traffic duplication, which, let's say, theoretically one could say is not a split or switch. So it's another functionality, but it's also that it's very supported by DoT-TSDSI. So you can configure the policy to send the same data or over the two links, so to duplicate. Next slide, please. For the inter-PLMN, again, you see in bold some different aspects. Of course, now it's between two PLMNs. So maybe you also here there is the assumption using a single subscription, the anchoring in the home. In this case, also there is the second requirement covering the seamless mobility, which is of course also a very important aspect. Also, the next one covers service continuity, and the third one is the one I described before, that also you have the case of multiple data sessions, where one uses dual connectivity while the other uses single connectivity. Next, please. Continues on inter-PLMN requirements. There are some that now introduce also the charging, so the ability to collect, of course, charging specific for the traffic sent over a specific link, because there could be also different billing for the tube. And again, you see some other example of different policy and criteria. And next, please. I think these also cover, some extra requirements. For example, at the top, there is the case of switching the second link from one BP element to another. So that's also another specific requirements. And then you see again the use case where, one of the terrestrial access can be also via GNOB or IAB node on UAV. And then the last two, as I mentioned, they generalize the support of for VPMN and mobility with the TSS. That's all in terms of, again, overview of the requirements, but you will see from the next meeting onward that there will be a consolidation, probably a smaller set which merge and converge the different aspects covered by those potential requirements. Next slide, which is the last one. That's also from my side a little bit of the planning. So next meeting we will see new use cases, we'll add new requirements, and we start to consolidate. And then in May, as per plan, we will finalize requirements, conclude, and send a TR to SA for approval, together with approving a WID, which is described on the right side. The WID is the mini project to basically introduce then these requirements into the normative specs. And that, as per overall plan of the release 19 in SA1, has to be ready by latest November 23. That's all from my side. Thank you very much again.
Thank you, Francisco, and I think thanks for the great presentation. And it's kind of amazing, how this one simple concept of multipath TCP, which was brought by IETF, has propagated and enabled so many things in 3GP, specifically with respect to AT-SSS and all these things which you just showed. So thanks a lot for this presentation. We will now go to our next speaker, Dr. Yang Zhu. Dr. Yang Zhu is a principal engineer in Beijing at Oppo Communications and has been involved in system architecture of the mobile network regarding 5G Advanced and 6G. He holds a BS and an MS degree from Xi'an Jiaotong University. And over to Dr. Yang for the next topic. Thank you.
Thank you. Can you hear me?
Yes, you are audible.
Thank you, everyone. Good morning, good afternoon, good evening. That is my pleasure to take this opportunity to introduce you about something about the AML work in the SA working group. So this topic is release 19 AML phase 2 work for the 5G architecture enhancement. So if you go to the next slide, I would like to have some background introduction. That now actually we are in the release 18 study in SA2 still, And we are focusing on the UU interface to how to enhance the 5G system to support the AML service, which is the AML phase 1 study ongoing. And we just finished the conclusion in last December. Now we are in the release 19 monitoring work, expected to be finished in this June this year. And meanwhile, we have this release 19 requirement in SA1 that's focusing on how to use the SatLink to better support the AML service. And what we expect that we will trigger the release 19 AML phase 2 in SA2 after June 2023, and considering both leveraging UU interface and SatLink interface. Okay, so if you go to the next slide. Yeah, this is a summary about my slide. I would like to introduce how the 5G system can assist to the AML service in these 5 aspects. And the first bullet about leveraging SatLink for the AML service is the new requirement from SA1. And the following 4 bullets is some remaining issue that we expect to be studied in release 19 from SA2. Okay, so if you go to next slide, firstly, I will introduce about leveraging SatLink for the AML service. Currently, we have a study item in the SA1 named AML MT phase 2, and which is focusing on the SatLink-based AML service. And we just identified 3 kinds of scenarios as listed in this page. First is about the scenario 1, that's about SatLink-based task offloading. That means currently, if you know the proximity-based service, that's mainly using the SatLink or the relay UE to support the communication service. And then we think in the future, not only the relay UE or the SatLink can be used for the communication, but also can take some computation offloading from the remote UE or some UE who requesting this. So in this scenario 1, it's basically like UE to offloading some AI inference task to another UE in proximity. And by doing so, not only the UE can use its own local data to have a high accuracy inference, but also it's offloading the task to some other UE that the UE will save a lot of computation power. And also theoretically, the UU interface the impact to UU interface can be minimized or avoided. And the scenario 2 is about the SatLink-based model distribution. That's very easy for understanding that we use the SatLink. We study mainly about the KPI and how to use the SatLink to support the model distribution based on model size and define the required data, bit rate, latency, etc. And scenario 3 is about SatLink-based federated or distributed learning. That means we can currently, when we talk about federated learning, we mainly think about the how to use the UU interface to involve a lot of UE to do a federated learning organized by a centralized server. Then if you can use the SatLink, you can involve some UE who are actually out of coverage or have bad queues in the UU interface. Then the performance of the federated learning can be greatly or obviously increased. So that's the purpose for this SatLink-based federated learning, to involve more UE for better federated learning consequence. So regarding to the gap analysis, if you check the left bottom part, the expected 5G as enhancement would be how to study how to leverage the SatLink for AML operation, including enhancement to discovery, queues, policy, and service continuity. Okay, if you go to next slide. Next slide is about the information exposure to the application in UE. That, as you know, currently the information can be exposed to the application server only, but we do identify some use cases and scenario that you need to expose the information to the UE directly. To do this, because it has some following benefits. The first is that if you do this direct notification to UE, it can help the UE to get a high accuracy and fast notification, which can be used to help adjust the application layer behavior in time. That is very important, especially in some real-time service like auto driving or AR/VR service. And the second one is UE need not hold a connection to application server, especially saving the signaling for idle mode. So that means the UE may not always have a connection with the application server. And when some very urgent information needs to be notified to UE, the 5G system should have some common, have some more efficient way to directly notify it to the UE. And the third one is the AFS work for the adaptation to 5GC can be simplified or avoided. This means that there's a thousand application could be installed in the UE side. So it's impossible for all the UE to understand the API defined by the 5GC, and that will be a huge adaptation work to let those applications in the UE to get the information from the 5GC. So we would like to check how the 5GS can be enhanced to provide a very simplified profiling or some other way that to avoid such kind of adaptation work. So on the bottom side, we have two scenarios. The first scenario is about the AR service that you need to keep transmitting data both uplink and downlink with the remote computation server in the application side, and actually this kind of a service can be adjusted by, for example, changing the model splitting or changing the codec based on the communication queues situation. So if the queues is degraded, let's say, then you can just quickly tell the UE side to do some behavior in order to avoid some service interruption. And on the right side, it's about the auto driving scenario. We have mainly two patterns. The first pattern is that most of the analytics or inference work is done in the UE side, but the UE still need to get the HD map data in time. So you need the UEs need to keep knowing whether the queues is sufficient enough to get those HD map data. And the pattern B is like the left side AR example. You need to have a constant communication with the server side. So you need to have a good queues. So you need to something if suddenly happen, you need to tell the UE because UE is the determination point. Okay. If you go to next slide. Next slide is just a gap analysis, some potential enhancement in 5G system. First is we need to find a way for the direct exposure to the UE. And second is the efficient information adaptation. I will have more introduction next slide. And the third one is the real-time pre-alerting with high information accuracy. That means you should provide the UE very high accuracy information. Otherwise, the UE may do something wrong based on a wrong information. Okay, if you go to the next slide, it's the third aspect about the AML translation. The main idea behind this is that currently, you know, in IC2, in 5G system, we defined tens of APIs, what we call service operation, and they are evolving from release to release. So it's very difficult to the third party to use it, to fully understand it and use it. That we call the huge adaptation work. So what we think is that we can use some so-called AML translation way, that we just provide the third party a very simple profile and like them to, just like the example in the bottom side, to add what they want, the information. Then the AML translation can help to interpret it and identify which 5G network function is needed to interact, and also invoke those service operations or related message or procedures. Just like the example in the bottom side, if the third party would like to get the prediction of UE service experience in a geographical area, if you push such a profile to the AML translation, which in the 5G system, it can help to interpret, to determine those 4 procedures listed in the right side, and to simplify such service exposure work for the third party. Okay, so this is the third one, and fourth one is if you go to next slide. So thank you. Okay, this is about the 5G system assisted cross-domain AI training and inference, which we usually call the vertical federated learning. And currently, when we do some model training or federated learning, it's just focus on one domain, like the application service. They can only use the application domain data to do some model training or federated learning, etc. However, in the release 19, we would like to see how the 5G system to assist to have a cross-domain AI training. That means, just like the example showed in the bottom left side, that different domain, like let's say UE is one domain, the 5G NF is another domain, and the application service another domain. They have different kinds of data, and they actually this kind of data, due to some privacy or security issue, cannot be shared to each other. Then you can think how to leverage the vertical federated learning to have those data to train a model together. Just like the right side picture shows, that if you have a more data from a different domain to train the model, the estimated QoE, that is something what we call tag in the application layer, can be more accurate. Because all the things we do, so no matter it's the communication or the application behavior, is to have the best QoE. So the tag is usually in the application side, in the application server. So the application server can organize the UE and the 5G system to do some vertical federated learning in order to have a better AI inference performance. That's this slide what I want to say and to study. So if you go to next slide, it's about the gap analysis for this kind of vertical federated learning. So by doing so, the 5G system may need to realize that the 5G NF and the UE can perform the training and the inference being requested by the application server. And also you need to like the 5G system to help to have some management of data and information for the vertical federated learning and the inference. Because for example, application server may not know which UE and network function has the data who requested. So the 5G can help to discover those network function or UEs. And of course, we need to think about how to enhance the queues and policy for this new kind of service, vertical federated learning and inference. Okay, if you go to next slide about the last aspects, it's the transfer learning. And we also think the 5G system can assist a lot to the transfer learning. The scenario or the background for the transfer learning is that usually for the AI training, for the AI model, even more than 99% of an AI model is not trained by zero, or what we call trained by scratch. It's not, it usually trained based on some pre-trained knowledge, or we can say by some pre-trained model. Then you adjust this pre-trained model to the target domain, to the target service, and apply it. So this is basically what the AI model training does. And then what we call this kind of thing is what we call the transfer learning. And basically, if you check the right side picture, and the transfer learning can help to greatly increase the training efficiency. As the three curves shows in the right picture, the B only picture is actually the UE does not use any transfer learning, just use their local data to train some model. Then it's like this performance. And then if you use the transfer learning, that means you find some similar people who share the similar characteristics with you and already have some pre-trained model, and you use it and to further adjust it based on your local data, then the performance can be greatly increased, like the upper line shows. But to the contrast, if you find some people who are dissimilar with you, then actually the performance is even worse without using compared to without using this transfer learning. So the 5G system, since they have a lot of data, they have a global data for many UEs, so they can help to find some UE who are share similar characteristics, and then help to identify the UE who can do this transfer learning, just like left side picture shows. So this is the scenario. And regarding to the gap analysis, in the release 18, actually, we have just defined the member selection assistant functionality. This is used for the federated learning server to find those super UEs by leveraging the valuable data in the 5G system. Then with some enhancement, you can also use this kind of functionality to do the transfer, to support the transfer learning by finding some people who share the similar characteristics. So this is about the gap analysis. Okay, this is all 5 aspects I'd like to introduce to you for the AML phase 2 work in release 19. So if you go to next slide. Yeah, this is this is a logo we designed for this AML study work. And we hope the artifact intelligence can make the world a better place. Thank you very much.
Thank you, Dr. Yangzhou. I think it was a very great presentation, and I think we are on the tip of the iceberg, especially with this this study. And I think much more is going to happen probably in the later releases as well. So thank you for this very engaging talk and very, very interesting topic. I think we'll go to the next speaker now. Yeah, our next speaker is Mr. Srinivasan, who is the head of India standardization at Nokia. He actively contributes in 3GPP RAN 2. He's very accomplished in terms of standardization, has more than 20 years of experience, has been participating from, contributing since release 9 onwards in various RAN working groups. He's also an active contributor in TSDSI on radio network related topics, and currently looking at mobility enhancements, IoT, and TN. So I would, like Mr. Srinivasan to take over for the next presentation. Over to you, Srini.
Yeah, thank you. So yeah, this is on the integrated communication and sensing. So this is to bring in the sensing capability to the cellular network base stations and the UE, and that would enable the whole 6G network to cater for a new kind of applications. So that's the main background. So the agenda briefly consisting of background motivation, and we provide a brief concept overview and the timelines and scenarios in 3GPP on this study item. And at a high level, what are all the system requirements and KPIs defined in the 3GPP TR? And we'll briefly look into the realization of this particular integrated sensing and what would be the building blocks needed at the cellular system side. The next slide, please. Yeah, background motivation. No, I think it's in 5G advanced and also in 6G. If you look at the 6G, the new aspects, if you leave out the new spectrum and extreme connectivity, which would be a natural extension from 5G, the new characteristics of the cellular system of 5G advanced and 6G would be, one would be bringing the artificial intelligence into the native air interface and multiple aspects, and then expanding or converting or the 6G network behaving as another personality, like network act as a sensor. So this is an expanding into a different application. So that would be a potential technology component even for the next generation. And in release 19, we are trying to find some initial studies and form the framework for 6G to further work on this network as a sensor. And in the right hand side, briefly, we have explained that key components. So that sensing means actually that particular access point would send some electromagnetic waves to the passive objects, and based on the reflection it will estimate the characteristics. So that can be done as an independent sensing only access points, or it could be integrated into the existing cellular base station, which actually meant to do a communication. So the integrated is the key part, because the operators can make use of the existing cellular infrastructure and base stations that can be converted into a huge number of sensors into the field. So that's the main motivation, and still in some cases there would be a possibility to have the sensing alone done by an access point also. Next slide. Yeah, this is a study item in 3GPP SA1, and the technical report is in progress, and it is expected to complete by Q3 2023, but there could be a slight delay, which may end up in completing by Q4. Again, as in on any other SA1 work items, this work item focusing on what would be the main use cases and scenarios to be addressed, and based on those use cases, what are all the actual requirements for the system level, what would be the minimums at a high level support needed at different network entities, and also roughly maybe at a high level KPIs to be achieved for this particular new technology. Because in some study items the KPI may not be critical, but since we bring a new capability, how the sensing really performs from a cellular when you bring that new technology, like sensing accuracy, and then how the sensing works depending on the object speed and other things. So those would be captured as a boundary, so that the solution needs to meet that minimum performance. Next slide. Okay, there are set of use cases. We'll briefly touch upon them, and something would be naturally fitting in would be the factory industrial IoT, because the factory would mostly consist of the automatic guided vehicles, and it is essential that these automatic guided vehicles or the base station in that will have some integrated sensing capability, so that they avoid collision when those automatic guided vehicle movement, and also based on the sensing, the automated operations can also be more accurately done, in addition to even the actual communication from those automation process. For example, lifting a particular package from a moving robot, and that lifters needs to be activated, it now can make use of the sensing and the actual communication coming from the other side. So this would be a natural fit into the existing industry 4.0 applications. But there are something else, some other general applications also possible, like UAVs. When we have multiple number of UAVs onto the air, I think the traffic is okay, the steering of the UAVs and avoiding collisions, and also maybe sensing something on the ground, and based on that providing some information to the base stations. Such things would be possible when the sensing is integrated into UAVs. And the next one would be on the traffic monitoring, when the crowded places, to estimate a number of people around this place, and accordingly the network can do some beam forming kind of things. Those could be the other use case. And yeah, next slide. Maybe next two slides touches upon the key use cases. Next slide. Yeah, again, it's in the big shipping kind of automatives. Also, the automatives mainly, I think this is also useful for an V2X kind of scenarios, like automated driving and then platooning, where if these vehicles have some sensing capability, then it can know and estimate the vehicle movements, and accordingly it can steer the driving. So it would be also, I think the V2X next steps would be to integrate the sensing into it. And intruder detection, maybe to monitor a specific area where if an intruder coming in, So there the sensing could be used. This may be an existing scenario somewhere else, but now the such things can be integrated into the cellular system. And also in general, monitoring the environment and accordingly steering and also predicting that environment and providing that information to the external things. Next slide. These are all further things. Health checking, I think the sensing based on the characteristics, some health monitoring seems to be also possible, which also require further study on how this based on this reflected waves characterization, this health aspects could be estimated. And localization, normally localization would be done based on positioning estimation, but now sensing also could kind of assist or interwork with that to make that more perfect and more applicable for a given and specific scenarios. So these were all the use cases, and that study also covers the privacy and protection, because sensing could be used for integrated communication enhancement and communication enhanced sensing, but sensing as such can be an application within the cellular services, and that could be given to a third party. So that privacy about the sensing information and how this to be protected when this information is exchanged from the cellular system to others, and ensuring that that only being used by the right endpoints. That would be another aspect would be studied as part of this 3GPP study item. Next slide. Okay, I think as of now, the draft high-level requirements which came out of the initial use case analysis. Interestingly, we are expecting a network, the base station, to have a sensing capability, so that the base station can sense what's happening around that base station in the environment, and that could be communicated internally for some external purpose, or that could be used to improve the communication itself. But at the same time, the device, the smartphone, which is also expected to have a sensing capability, because as we see the V2X kind of scenarios, and also the mobile having the sensing capability would enable some environment information from multiple mobiles getting collected to the base station, that would give an overall big picture about an environment. So each smartphones acting as a individual sensors, maybe then finally it would look like it would be like a sensor network. That capability also expected as part of this work item. So UE having sensing capability means UE should be able to send some waveforms to the neighboring, the surrounding places, and then receive and characteristics, and this information needs to be passed back to the network. And UE should be able to do the sensing over licensed and unlicensed band. This is on maybe the radio aspects of where and all it should be possible. So right now, licensed and unlicensed band boards are covered here. And in addition, there should be a control from operator on the window where the sensing from the base station can be activated, and which areas it should be activated, and the window, and maybe a command based activation, deactivation. It's like a network control capabilities also defined as part of this system requirement. But this would be a starting point at SA1. Maybe further granular requirements on how this could be achieved, and the radio capabilities and processing capabilities would be defined at the next level, stage 2 or the SA2 level work. Next slide. Yeah, maybe the draft KPIs defined as of now are maybe how much would be the sensing service area. That means around which areas the sensing is applicable, or the network would be able to do the sensing. I think this is these particular KPIs will be different for different use cases. So that one example given here is intruder detection. What would be the KPIs? So the confidence level of sensing information, and accuracy of positioning, and accuracy of velocity estimate. Velocity estimate would come into picture when the sensing is used to predict the velocity of a moving object or even the mobile itself. And then sensing resolution. This would come into picture how the sensing really predict the object itself, object size, shape, and then the characteristics, maybe the depth and all such things. So that would require some minimum performance requirement. And how this overall sensing procedure will get executed and what is the latency by which this should get completed. Again, it depends on the use case. In some use cases, it may be used for some post-processing kind of thing. In such cases, latency doesn't matter. But if a sensing-based action is expected to result in an immediate service action, then the latency plays a critical role. And refreshing rates, this mainly because sensing means the network needs to scan the whole network via some beam sweeping kind of thing. So the refreshing rate also important. How much refreshing rate would be needed? That would in turn also affect network's energy consumption part. That missing detection and false alarm is more critical because I think that sensing outcome is being used for further prediction and algorithm. So this misdetection and false alarm should be as minimum as possible. It would be defined for all the use cases what we have seen. But here I have just given an example for one of the scenario. Next slide. Okay, until now we have seen what is the study item scope, the use cases, and how the use cases got converted into a system level requirements, and then what is the KPIs of those sensing technology performance. But now later, once these requirements are in place, then which are all the components get affected, or where there would be a realization of this overall sensing feature. So that is depicted at a high level in this particular diagram. So mostly we need to have a base station having this radio protocol stack, which can process the sensing information. And if you look at the transmission and the radio processing side, there would be a transmission that would transmit the beam for sensing, and it will have a receiver on this operating on the same band and frequency to get back the reflecting waveform. That reflected waveform needs to be analyzed by comparing itself with the transmitted waveform, so that that would result in the sensing information. So I think maybe in the next slide we touch upon. So it is already it requires full duplex kind of capability at the base station. That means the transmission and reception needs to happen on the same band simultaneously. So the transmission side should have some self interference suppression kind of thing, and to detect the reflecting back signal which is coming immediately on the same band in a quicker manner. So that would be the case. So this integrated part, there would be the beams for real communication purpose, which would be communicated towards the UE, actual UEs, and there would be the same beams, or some of the beams could be focused on the objects, and from that the reflected things will come via the receiver beam forming. So the receiver would do this beam refreshing across multiple direction, and when it senses the similarity with the transmitted beam, it can start estimating the object realization, the characteristics related things. And main thing would be, because sensing would be at a high level information on what is being the transmitted waveform and reflected waveform differences, but the information needs to be given to some AML training, which would finally result in the right prediction and characteristics estimation of the object. That needs to be done using the AML. So AML plays a key role in this part. I think I'm running out of time. Maybe next slide. That would be the last one, I think. Yeah, I think this is just slightly more details into the radio aspects of it. Maybe the scheduler, if you say in the downlink, it may need to define reference signals or the sensing burst, which would be interlaced with the actual communication subframes. And then that sensing burst would be reflected, and that would be processed into the receiver part, and that will be further processed by the AML modules. So this is just more detailed block diagram of how the sensing would be realized in the base stations. And this only covers a base station acting as a sensor. When UE acts as a sensor, that would have a different aspects. Last slide. Sorry. Just it's an example it's maybe sensing can be integrated. Sensing itself can be integrated along with the camera-based sensing and the electromagnetic wave-based sensing. These both together can interwork. If those informations are processed in a training in a AML model, they can provide more accurate and interesting information of representing the environment. Just an example, this could be further explored of combining the camera-based and EM wave-based sensing as one service and solutions. Thank you. I think I just taken some few minutes more. Sorry.
No problem. Thank you, Srinivasan. I think this was a great presentation, and I would like to thank all the speakers, all the 4 speakers who have presented. And I think now we should go to our next section. I'll see about 175 attendees, section on the polls. So I think this is we are trying to gauge the interest in these topics that we presented today from the audience. I would like the audience to stay very tuned and help answering these polls. So I think let's go ahead with the first question. Asif, we can flash that on the screen. So I will read it out. How familiar are you with the 3GPP standardization process and release timelines? Please select one. The options are very familiar, somewhat familiar, and not familiar. Call that in the first presentation from Summer, this was highlighted. So I request the attendees to kindly give their poll. So I think I hope most of the people have been able to answer. So we'll go to the next one. Question, Asif, if you can flash the next question for the audience. Question 2 is, do you agree that a dedicated workshop about the 3GPP process is required? Again, we are asking the question to select one of them. The options are strongly agree, cannot contribute without that, partially agree, it can be useful, but I can still manage, don't agree, not really required. So I would like the audience to kindly select what is appropriate. This would help us gauge if any further workshops are required or not. So that is the main motive behind this poll. And I request the attendees to kindly select what is appropriate, and this is feedback that we will use for future workshops or any programs as required. So let us keep this for some time. Now we'll go over to the next poll question. If we can flash that quickly. This is related to the topics that we presented today. I'll read the question, and the question is, which of the following does the organization have a strong business or research interest? And you can choose multiple options. So I think the 4 topics that were presented today, the service robots by Dr. Kidong, the upper layer traffic steering by Francisco, the AI/ML models by Zuyang, and then sensing and communication by Srinivasan. Whatever is your area of interest, kindly tick on those. I mean, you can tick more than one, or if it is none of these, then that is also an option which is presented. So I request the audience to kindly choose one of these. I hope the topics today were useful, and definitely there is some alignment which people had, or some thinking which people have based on the information shared by the presenters as to what is of interest to them, and where people think they can contribute. We can now go to flash the another question, the last question on the poll. So, which of the following topics is your organization interested in contributing to 3GPP? Please choose all that applies, and again we have the same options as the last question: the service robots with ambient intelligence, upper layer traffic steering, AML model, sensing and communication. None of the above, so you can choose whatever is appropriate. You can choose more than one, of course. So here the question is very similar, but we are more interested in what the organization that you belong to is interested in. So kindly choose all that are applicable. So I hope everybody is able to follow these poll questions and able to answer. Just keep it for maybe a minute and then we will go over to the next. Yeah, I think we can close the poll now. I think we have given sufficient time. So I hope the audience found the workshop today interesting, and I would like to introduce Mr. Toshniwal. So can we go to the next slide for making the closing remarks? Let me just briefly introduce Mr. Toshniwal. Mr. Toshniwal is an Indian, is a telecom service officer of the 1990 batch. He has extensive experience in various telecom domains, including wireline and wireless. He is currently part of the DoT headquarters since 2021 October as a DDG Networks and Technologies, and also serving as the co-chair of the TSDSI Roadmap Committee. So over to you, Shri Deen Dayalji.
Thank you, Mr. Anindya. I hope I am audible.
Yes, sir. You are. Please.
Okay, thank you. I thank all the participants for attending this second workshop in our series of micro workshops on advancing 5G towards 6G, which has been which is being organized jointly by DoT and TSDSI. This workshop, that is the second in this series of workshops, focused on the theme technology and systems. We are very happy with the overwhelming response that we have received from all of you so far. Also, I would like to take this opportunity to thank everyone who have sent their information in the expression of interest form. The expression of interest form is nothing but a feedback form that is very critical for us from a follow-up perspective. So I request everyone to take a few minutes to answer the questions. It is very straightforward. Also, I would like to take this opportunity to request each and every one of you to spread the word on what TSDSI is trying to do, and forward the registration link of the next workshop to your fellow researchers. The next workshop would be on the 27th of this month. In this workshop, our distinguished speakers from across different geographies covered details on some very interesting and exciting topics, such as service robots, upper layer traffic steering, AI/ML models, and sensing. We are highly indebted to the eminent speakers for sharing their experiences and thoughts with us. These are some of the topics where there are several works items in 3GPP release 19. And if any of you or any of your colleagues are working on these areas or other related areas, we would like to hear from you. Our primary goal for this workshop is to spread awareness and about standardization work across the broader telecom ecosystem in the country, so that more and more people join us in this journey. TSDSI experts have spent considerable time and energy to make this workshop possible in a very meticulous manner. We encourage each and every one of you to use these resources very effectively and join us. You would also appreciate that standardization work is a collaborative effort, and members will get a chance to work with the best and the brightest in the industry. TSDSI has built a space that is conducive for research work. TSDSI has members across startups, academia, MNCs, and the broader Indian industry. and it would be very exciting to work with such a constellation of bright minds and contributing very meaningfully towards India's role in 6G standardization related processes. Once again, thank you for joining us, and see you all at the next workshop. Thank you, the organizers, and thank you, Anindya. Back to you.
Thank you, sir. So I think what I understood is that the results of the poll are available. So I would request Asif, who is managing that, to kindly flash that on the screen. So I think this is for the first question. How familiar are you with the 3GV standardization process? I think, yeah, it looks like people are somewhat familiar, 62%, and then there is still a bunch of people who need help. Do you agree with the dedicated workshop is required? So it looks like yes, the majority is saying that yes, a dedicated workshop is required. I see 70%. So I think we kind of get that. Let's go to the third question. This is interesting. So which of the following does the organization have strong business research interest? So it looks like sensing, AI, ML are on the top, which is not a surprise. And of course, then traffic steering, and then robots. Let's go to the fourth question. Which of the following topics is your organization interested in? So here again, we see AI, ML, and sensing being on the top, followed by traffic steering and service routes. So thank you. I think this is I think the poll kind of tells the drift of what the audience thinks is their interest. So thank you for conducting this poll. And I would like to just close by thanking the speakers once again. I think a lot of them, I mean, most of them are in different time zones than India, and they have taken great pains to be very strong ambassadors of 3GPP and really help us conduct this workshop. So I would like to appreciate and thank each one of them again. And I think we can, I'm already running out of time, so we would like to close now. But then before closing, I wanted to remind everyone for the upcoming workshop on 27th, which is the micro workshop 3 on vertical applications and services. So this will also be, I would like everybody to register for this at the earliest. The messages will soon go out. You can see the QR code which you can use to scan and definitely register. So with that, I think we can close the workshop. Unless there is something else, Guna sir or Samar, you want to make?
Some hygiene questions
No, we are
we
good.
can see in this one.
We are good, Anindya. Thank you for being a great anchor. Thanks, everyone. Looking forward to seeing you on workshop 3.
I think there was a note about the questions. So I think the audience question, Asif, what were you saying?
The question posed by Miss Ramya Veena has been already answered by speaker, Mr. Ki Dongli.
Okay.
And some
Yes.
hygiene question related to recordings. It will be shared after a few days in the event website itself. There is some other question regarding recording itself. Yeah. So workshop 3 link somebody is asking. So I'm pasting that workshop 3 links. Let me just do quickly.
I think anyway it will be sent out to the people who have registered for this workshop. But anyway, I think I'll let Asif paste it here. I think especially workshop 1 and workshop 2, we have tried to do our best possible to show the kind of work being done in 3GP and arouse interest. And definitely would like more people to join in workshop 3 as well as we continue that journey. Yeah, Asif, where is, on which window are you pasting the?
Just to add, Anindya, maybe people can take a snapshot of this window and use this scanner, the QR code to register.
Yeah, I'm sharing in the chat to everybody. So
Yeah,
the registration link, right?
Am I audible, Anindya?
Yeah, you are very clearly audible, but I would I think Asif wants to display it in the chat window, so I
Yeah,
think I will let him go
I
ahead.
have shared the link for the third webinar registration links. I think we
Okay.
got one more question from Uttara Sound, but it may take offline because we are already delayed.
Yeah, I think we are already running out of time, so I think please send the questions to the organizing committee, and then we will answer them offline with the help of the speakers who are already there today. So with that, if we can close the workshop. Thank you everyone for joining, and thanks to all the speakers for their enlightening talk and helping people understand the kind of work which is being done and what is coming ahead. Thank you everyone.
Thank you, everyone.